You arrive here tonight with a quiet curiosity, a soft question humming at the edge of your awareness. Maybe you have settled into bed, or onto a couch, or into a deep, familiar corner of your room where the light fades into darkness. Wherever you are, this moment is yours, a small sanctuary carved out of the noise of the day, a place where the universe feels close enough to touch even as its mysteries stretch far beyond comprehension. Breathe gently. Let your breath slow, like the dimming of a lantern, because tonight we are drifting into something strange, something delicate, something that, if you take the scientists at their word, should not exist at all. You see, every once in a while, the universe allows us to stumble upon something impossible, something that doesn't fit, something that breaks the quiet, logical order of physics the same way a single cracked note can change the entire sound of a symphony. And this story, the particle we're about to explore, begins with such a crack. Before we begin, settle your mind. Nothing here is rushed. Nothing demands perfect understanding. You are not required to follow every detail. You are simply asked to drift with me, to feel the soft, trembling edges of a discovery that bends reality in a way that even experts whisper about. Tonight we explore the particle that should technically break reality. Let your breath deepen and imagine the universe around you widening like a vast dark ocean unfolding at the speed of thought. Now, let us begin. To understand what makes this particle so strange, imagine the universe as a grand, ancient machine. Every gear fits perfectly, every motion is predictable, every particle, every electron, quark, photon, neutrino follows carefully written rules. Rules so consistent that physicists sometimes describe them as the grammar of reality. For billions of years, those rules have held steady. Stars formed and burned by them, atoms assembled by them. Your body, your breath, your thoughts, they all exist because the universe obeys these rules with exquisite precision. But every machine, no matter how perfect, has weak points, small seams where the edges don't line up. And sometimes, physics stumbles upon something that slips through those seams, a particle that behaves as though it belongs to a different rulebook altogether. A particle that suggests the universe might have deeper layers, hidden chambers, places where the old rules melt into something stranger. This is where our story begins, at the boundary between what physics can explain and what it cannot. Breathe softly. Let the idea rest in your mind like a feather settling onto water. It began in a quiet laboratory, not with fireworks, not with explosions, but with an anomaly, a number that didn't match the expected number. Physicists live by numbers the same way poets live by metaphors. Numbers anchor the world. Numbers keep reality consistent, so when one number refuses to align, when a measurement falls outside the boundaries of what should be possible, the entire scientific world shifts slightly, like a floorboard creaking under your feet. This anomaly came from an experiment studying muons, particles similar to electrons but far heavier, almost as if the universe accidentally packed too much mass into them. Muons are usually predictable. They spin, they wobble, they behave exactly as the laws of physics say they should. But then something happened. In a subtle but undeniable way, they didn't. Their spin shifted, their wobble bent, their motion drifted into a pattern that no equation could account for, as if an invisible hand had brushed against them, nudging them out of alignment. Imagine a spinning coin on a table, perfect, balanced, silent. Then imagine someone breathing on it, just the faintest breath, and suddenly the coin veers, wobbling in a way that defies expectation. That is what the muons did, and buried inside that wobble was the first whisper of a new particle, a particle that should not exist, a particle that, if real, would break the standard model of physics wide open. The standard model is the blueprint of reality. If you break it, you aren't just discovering something new, you are discovering that everything we thought we understood might be incomplete. Let that thought drift through your mind. Incomplete reality. unfinished physics, rules written only on the surface, while deeper truths wait in the dark below. The scientists ran their experiment again and again and again, over months, over years. Each time, the same ghostly signature appeared, like a faint fingerprint left behind by something we could not see. Not a particle in the traditional sense, not something you could hold or imagine, something stranger, a virtual force, a tremor in the quantum field. A ripple from a particle that flickered in and out of existence like a mirage shimmering above hot desert sand. What was it? Some said it might be a new boson, a messenger particle carrying a force we have not yet discovered. Some whispered about supersymmetry, a long-theorized but never proven partner to every known particle hiding behind the curtain of reality, and others believed it might be even stranger, a particle connected to dark matter itself, the invisible substance that makes up most of the universe, yet cannot be touched or seen. Whatever it was, it behaved like a fracture in the universe's operating system, a tiny glitch in the cosmic code, a particle that shouldn't exist, yet somehow did. When you breathe slowly, you might feel a faint echo of that mystery settling over you, a reminder that reality is not the rigid structure we assume it to be. It is elastic, it shimmers, it hides secrets in places we rarely think to look. Imagine you are standing in a long hallway, a hallway you have walked through your entire life. The walls are smooth, the lights are steady, you know the path by heart. This hallway is our current understanding of physics. Predictable, clean, well lit. But then, one day, you notice a hairline crack in the wall, barely visible, so faint you might miss it entirely. Yet if you press your fingers against it gently, cautiously, you feel a breeze coming from the other side, a place that should not exist, a space not in the blueprint. That crack is the muon anomaly, that breeze is the impossible particle. And physicists have realized that the crack might not be a flaw, it might be a doorway to new forces, new dimensions, new symmetries, new realities written beneath the one we live in. Some theories suggest this particle might be a portal interaction, a piece of the mechanism that connects our universe to hidden layers of reality. Others hint at a fifth fundamental force, one that binds space in ways we have not yet sensed, and some whisper about hidden sectors, entire families of particles that coexist with our own but rarely touch us. A parallel physics, a shadow version of reality, not supernatural, just deeply, deeply unexplored. Let your breath settle, let the idea float. Now imagine yourself drifting in darkness, calm, weightless, unhurried. The universe stretches around you, soft and infinite. In the quiet, you sense something subtle, a tension beneath the fabric of existence, a reminder that everything we see, everything we understand might be only the surface of a much deeper ocean. This is what the impossible particle represents, not chaos, not destruction, but revelation, a soft fracture in reality, a gentle reminder that the universe still has secrets it has not yet decided to reveal. The scientists are still gathering data, still checking, still questioning. Because that is what science is, a long conversation with the unknown, and sometimes the unknown speaks back. Tonight, as you breathe softly, imagine the particle not as a threat to reality, but as an invitation to curiosity, to wonder, to the quiet, thrilling realization that the universe is stranger, softer, and more mysterious than we ever imagined. And this impossible particle, is only the beginning. There is a quiet moment that happens in every great scientific mystery, a moment when the researchers, after months or even years of chasing numbers and patterns, finally pause and realize that the universe is whispering something far stranger than they expected. It is not a moment of triumph, not yet, but a gentle unraveling of certainty, a widening of the mind, a small, almost fragile shift in perspective where what once felt solid begins to feel fluid, as if the floor beneath their understanding softens into something that moves, like the surface of a deep, dark lake. If you allow your thoughts to settle for a moment, you might feel a similar softening within yourself, a sense that the universe you thought you knew is slowly turning itself inside out, revealing layers that shimmer beneath the familiar. To understand this place we are entering, breathe slowly, as if inhaling the darkness that surrounds you. Let the noise of the outside world fade until all that remains is the hum of your own awareness. Because this part of the story is not about the anomaly itself, not about numbers or equations, but about the strange, dreamlike territory that opens when our models of reality falter. It is the territory where questions grow larger than answers. It is the territory where the universe stops behaving like a tidy machine and begins behaving like a living, shifting organism, breathing, growing, mutating in ways we never anticipated. Physicists have always depended on symmetry to make sense of the cosmos. Symmetry is the quiet orchestra beneath everything, the reason forces behave consistently, the reason particles mirror one another, the reason the universe doesn't collapse into chaos. Symmetry is the hidden spine of reality. And yet, the deeper scientists looked into the muon anomaly, the more they realized that something in this symmetry was trembling, not collapsing, not breaking violently, but trembling like a violin string played by an unseen hand. It suggested that something was influencing the muons, something subtle and almost elegant in the way it disrupted the rules without shattering them entirely, like a ghost brushing past a candle flame, bending it just slightly off-center. This trembling, this deviation from the expected pattern, didn't behave like noise or error. It had intention behind it, a structure, a rhythm. In physics, intention does not mean consciousness, it means coherence, the kind of coherence that often points to something real beneath the surface. Imagine standing at the edge of a still lake at dawn, the water smooth and silent. Suddenly, a ripple moves across the surface. You don't see the stone that caused it, but you know it was there. The ripple is proof. The anomaly was that ripple, a faint signal in the data, yet consistent enough to suggest a hidden stone, an invisible influence beneath the waters of reality. As the measurements became more precise, the researchers found themselves entering a strange liminal space. The numbers refused to conform. They bent around an invisible presence like starlight bending around a black hole. Not enough to be dramatic, but enough that the bending could not be ignored. And this bending raised an unsettling possibility. What if the particle responsible for this deviation wasn't just unknown? What if it lived in a layer of reality we have not yet touched, a layer parallel to ours, a layer woven between the spaces of what we call real? Some theories suggest that our universe might be only one of many, not in the sense of science fiction worlds stacked like pages in a book, but in the sense of overlapping domains, like multiple shadows cast by the same object from different angles. You can see one shadow clearly, but the others blend into the darkness, hidden yet still present. The particle affecting the muons might belong to one of these hidden domains, brushing against ours only in rare and delicate moments. It would be like sensing a heartbeat faintly through a wall, distant, muffled, but unmistakable. This idea, unsettling yet beautiful, became one of the quiet obsessions of the physicists working on the anomaly. Through equations and simulations, they were trying to listen to that heartbeat more clearly. There is a softness to discoveries like these, a feeling that the universe is not shouting at us, but gently guiding us towards something deeper. Scientists often describe this kind of work as feeling around in the dark. But it is a special kind of darkness, not the frightening, suffocating kind, but the kind you experience in a planetarium, where the lights dim and the stars appear above you, letting your imagination drift upwards into ancient, cosmic silence. The darkness becomes a canvas, a place of possibility, and that is what the anomaly became. A canvas for possibilities that stretched far beyond anything the standard model could contain. One possibility was that the particle belonged to a new force, a force so subtle and faint that it only revealed itself under specific conditions, like a whisper only heard in absolute stillness. If true, it would mean that the universe contains not 4 fundamental forces, but 5. This 5th force wouldn't be dramatic. It wouldn't toss planets across the sky or bend mountains. It would be quiet, hidden, the kind of force that shapes things from beneath the surface. a force woven into the subatomic architecture of matter itself, a force that nudges particles ever so slightly off their expected trajectories, leaving behind the faint ripples that physicists were witnessing. Another possibility was even stranger, that the particle existed in a higher dimension, one curled up so tightly that our senses could not detect it. Physicists call these compact dimensions, pockets of reality folded into themselves like intricate origami. In such a universe, particles could slip in and out of these compact spaces, appearing to flicker or vanish from our perspective. The anomaly's pattern, its rhythm, its persistence, hinted at interactions far too complex to exist in our familiar three-dimensional space alone. It was as if the particle lived partly here and partly somewhere else, a dual citizen of two realities. Let your mind drift for a moment into that idea. Imagine space not as a vast emptiness, but as a layered fabric. Imagine that between every atom, every breath, every heartbeat, there is a hidden complexity, a folded geometry humming quietly in the background, and every once in a while, one of these hidden folds brushes against our world, leaving behind a faint signature, a gentle distortion in the rules we thought were fixed. The particle's behavior seemed to reflect that exact kind of brush, like a shadow that doesn't match its object or an echo that arrives before the sound. What captivated scientists most was not just the anomaly itself, but what it implied. If the particle existed, then the Standard Model, our most successful framework for understanding the universe, was incomplete, not wrong, but unfinished, like a map that shows only the major roads while hiding the intricate pathways that connect them. This realization didn't bring fear. It brought a strange sense of excitement, a sense that the universe was once again inviting us deeper into its structure. Every time humanity has expanded its understanding of the cosmos, the transition has felt like this, like stepping through a doorway into a larger room, only to realize that the room has countless more doorways waiting. And as scientists walked deeper into this room of possibilities, they felt something else, something subtle but unmistakable. The anomaly wasn't just a clue, it was a message, not a message in words, but a message in behavior. The particle's refusal to fit into the known laws was itself the signal. It was the universe saying, in its own quiet language, "Look closer." There is a unique feeling that comes with sensing something real but not yet visible, like hearing footsteps in a dark hallway or seeing a flicker in the corner of your vision. That feeling grew stronger as more data arrived. It became clear that this wasn't random, it wasn't a glitch, it was a real physical phenomenon, a whisper from the unseen layers of existence. And with each experiment, the whisper grew slightly stronger, slightly clearer, like a distant melody coming into focus. For the researchers, this meant entering a state of deep, humbling curiosity. They were confronting the possibility that reality is not built the way we imagined, that there are cracks, yes, but not cracks that break the structure, cracks that reveal something beneath it, something older, perhaps, something more fundamental, a deeper symmetry, a deeper set of rules, a deeper version of reality, and that is where the true awe of this discovery settles in, because if this particle is real, then the universe is not just stranger than we think, it is stranger than we can think. It means there are forces at play so delicate we have only now begun to notice them. It means matter is influenced by energies that drift like phantoms through the quantum world. It means our understanding of existence has been built on the outermost shell of a much larger truth. As you breathe gently now, imagine yourself floating in that larger truth. Imagine the universe expanding around you, layer by layer, dimension by dimension, each one revealing new patterns, new harmonies, new geometries. Imagine the rules of physics unfolding like petals, revealing inner petals, softer and more mysterious than the ones before. And imagine the particle, the impossible particle, as the very first petal to open, a small, delicate sign that the universe is beginning to reveal its deeper architecture. This is where part 2 leaves us, in a place of quiet anticipation, suspended between what we know and what we are about to discover. The anomaly is no longer just an anomaly, it is a doorway, a beginning, a shift in the direction of reality itself. And the next chapters will take us through that doorway into the deeper machinery of existence that this particle is hinting at. There is a moment in the story of every scientific discovery when the mystery stops feeling like something out there and begins to feel like something woven directly into us, something intimate, something that almost seems to breathe with us. As the anomaly deepened and the hidden influence behind the particle grew more undeniable, physicists found themselves drifting into this very feeling, an awareness that the universe wasn't just misbehaving in distant laboratories or buried equations, but that the structure of reality itself was shifting in a way that touched everything, every atom, every beam of light, every thought moving through your mind right now. It all belonged to the same interconnected architecture, and somewhere inside that architecture, something ancient and unfamiliar had begun to stir. To step into that realization, let your mind soften again, let the edges of your thoughts blur just a little.